So we're gonna discuss how to maneuver functions, but the the example we're gonna use here is going to be our hyperbolic function and our straight line. So first thing is first, we're given f of x as that, and we're given g of x as that. Now the question says that you should get the asymptotes of f. So remember, the asymptotes, we have two of them for a hyperbola. We always have two asymptotes for a parabola. We have one asymptote for exponential. The rest of the other graphs, such as a linear, such as parabola, they don't have asymptotes, right? So we have two asymptotes, which is horizontal and vertical. So let me just write them down here, or let me just quickly make this a bit shorter. Okay, hopefully we can still see. So for 5.1, the asymptotes, let's start with the horizontal asymptote. For the horizontal asymptote, you check the value of q. Okay, remember this is the value of q because a hyperbola is a over x plus p plus q. So the number that is here is your q. If there is nothing there, then it means that q is 0. But your horizontal asymptote will therefore be y is equals to 2. Okay, so horizontal asymptote, we say y equals to something. Because when you say y equals to 2, you are referring to a horizontal line. You understand? Because if you look at your Cartesian plane, this is x, this is y. So when you have y is equals to 2, you are saying you are cutting the y-axis at 2. So that is what it means there. Then let's talk about the vertical asymptote. For the vertical, it's going to be that you check the value of p. So you want to check this. So your denominator there is x minus 3. So for a vertical asymptote, you just equate the denominator to 0. Equate whatever is the denominator to 0 and solve for x. That becomes a vertical asymptote. I hope that is clear. So that tells us that you see it says x is equals to 3. This means we are cutting the x-axis at 3. So it means it's a line that is like that. And from there, since your value of a is positive, remember that this is 4, is positive. So therefore your graph should be looking like something like that. So before you even do the actual coordinates of the asymptotes, of the axis, you already know the shape of the graph. 5.2 asks us to find the x-intercept. So to get the x-intercept, you simply let your y be 0. So that means we shall have 0 is equals to 4 over x minus 3 plus 2. Then you solve for x. You can take 2 to the other side. Then you cross multiply. You're going to have 4 is equals to minus 2 into x minus 3. So this is going to be minus 2x plus 6. So 2x will be equal to 6 minus 4. So I just took this to the other side and took that to the other side. Okay, so therefore you're going to have 2x is equals to 2. You divide by 2, x will be 1. So therefore your x-intercept is 1 and 0. Hope we're still together, sorry. And then 5.3. 5.3, we need to find the y-intercept. So how do we get the y-intercept? You let your x be 0. Remember that. So where you see x, you want to put 0. So you're gonna have so you're going to have y equals to minus 4 over 3 plus 2. What does that give you? What do you get? 6 minus 4 is 2, ne? So you get 2 over 3. So that is going to be 0 is 2 over 3. So using that, we can sketch the graph. So you might want to have your Cartesian plane. Then on that Cartesian plane, okay, like you can increase the Cartesian plane. We are working with f of x is equals to 4 over x minus 3 plus 2, and g of x is equals to x plus 2. So what do we then do? Remember that we have the equation of the horizontal asymptote, and let me use a ruler for. So we said y is equals to 2, so it's going to be this one. Let's use maybe a red color. Yellow, let's use yellow. Right, that is our nice dotted line there. And then we need to label it y is equals to 2. Ne? So then how does our vertical asymptote look like? Ne? We have to look at the fact that we solve for x at the top, right? I told you that you say the denominator and then you equate it to 0. And your vertical asymptote is x is equals to 3. So you might want to sketch that one. Ne? So how do we then sketch that? Let's do this. Where is that? Oh, x is equals to 3. It is gonna be here. Just make it nice, yeah. Yeah, it's gonna be here. Then let me use this one. Yeah. Oh, it's drawing on the wrong side. Okay. Nice. So now, what are we gonna have? We have ourselves x is equals to 3, ne? As our vertical asymptote. Right. So then now, let's see what we can do from there. Remember, we also got the intercepts. Our intercept was 1 and 0. Where is 1 and 0? I believe we can see that it is this one. This is x is 1 and then y is 0. Okay, please take note of that. And then you have 0 and 2 over 3, I believe, from what we got there. 2 over 3 is around 0.6. So we're gonna say 0 and 2 over 3, which is 0.6. So we can say it's something around here. Doesn't have to be too much precise. So what we can do, we can then do this one. You can join it like this. And then for this part whereby there is nothing, ne? Because you know the general shape that if a is greater than 0, your graph is gonna be in the first and second quadrant, the third quadrant. You're gonna do this. Do you see that? Guys, do we have that graph? Right? Exactly like that, guys. Perfect. Perfect, perfect, perfect. So this is our graph of f. So we can actually label it that this is f. Then we were asked to find the point of intersection. I think that was the question that was following this one. We needed the points of intersection. Yeah. Okay, okay, yeah. Let's also sketch G. Let's also sketch G. G of x will need us, it's a simple straight line though, but so if you remember, you just need its y-intercept by letting x be 0, right? You can then substitute 0 you see x. So if, as you can see here, this is 0. So you can say, I like to write this as y is equals to x plus 2 so that I understand that g is simply y. So then I say y equals to 0 plus 2, which means y is equals to 2, which means we have 0 and 2. Okay? So then once we have that, we can then say our x-intercept is gonna be, let's let y be 0. So now where I see y, I'll put 0. And then I'm gonna have x is equals to minus 2, which means you're gonna have minus 2 and 0. Right. So you can then plot the graph. So let's say I'm gonna, let me use a blue one. So minus 2 and 0 will mean is this one, and 0 and 2 means is this one. So it's a straight line. Yo, ish. Why is it like, okay, because you know what, I want it to be passing straight like that. Okay, it's fine. Let's still try to do it. Okay. Let me do it like this. I hope I'm not forcing it too much. Do you have something like this? For real? Oh, ish. And you know what? It needs to be long, eh? Can you try just to extend it a bit? Because some of the information is that we're going to talk about lies on that, relies on that. But otherwise, we can just still use this, right, to then answer those questions that I said we would talk about. Let's see. Let's remove this and then talk about the point of intersection. As you can see, this graph, right, these graphs, they touch at 2 points. They touch at this point, they also touch at that point. Those are our two very much crucial points, right? So what we need to do is to find the coordinates of those points, even though the question just wants the x coordinates. But let's see, how do we find the points of intersection? Remember, you have to let your f be equal to g. And then you then substitute 4 over x minus 3 plus 2 is equal to x plus 2. Now remember, you need to leave this alone, whichever way you can solve it from here. But maybe you might want to have the 2 to the other side, so that is minus 2. Then you have 4 over x minus 3 equals to x. Then you need to solve. Then you need to solve for x, right? Right. So then, what we can then do there, let's solve for x. we'll make this x over 1, so we have 4 times 1, which is 4, and then we're gonna have x into x minus 3, and quickly simplify. Okay, so it's gonna be x squared minus 3x. And then you're gonna have minus 4. It has to be minus 4 there. You might want to use the quadratic formula, or you can factorize depending on which one you feel comfortable with. So therefore your x must be minus 1 or x should be 4. Did we get that? That is great. That is great. So that is how we get the x coordinates of the point of intersection. And then to put them, or rather, if we go back to our graph, we said our graphs, they are touching at 2 points. That is why after equating the graphs, you got 2x values, because our graphs are touching at 2 points. If they were touching at only 1 point, you were going to get 1x value there. So I want you to see something. From our calculations, our graphs, they touch at x is -1 and x is 4. I want us to go back to the graph and then see if that is true. See if that is true. Check. You see, they touch at x is equals to -1. You see that? And they also touch at x equals to 4. Obviously, for me, I didn't sketch it quite nicely, but yeah, the other point there, x is 4. By the way, because this graph of mine that I drew for you, it's very much up to scale, you can actually then find the coordinates themselves. This coordinate here is gonna be -1 and 1. You see, this one ideally it should be 4 and 6, right? This point should have been a bit higher there. So, but then how do you find 6? How do you find 1? Because we know x is -1 and x is 4. You can just substitute either in this graph or in that one. You're gonna find that if you substitute -1 here, you get y as 1. That's why here we have 1. If you substitute 4 here, you get 4 plus 2, which give you what? 6. That's why the point there is 4 and 6. And then what can we do from there? What can we do? So maybe you might want to okay, actually from the question, there was no need of getting those y values, but we are putting those so that we can be able to work on it. Okay, we are putting these so that we can be able to work on it. So let's see. Once you have that, you can take your pencil. So I'm gonna remove this part. You can take your pencil and then do this. It's going to, yeah, it's gonna be fine. I think it's gonna be fine. So what you will do for me, you're gonna take your ruler. Yeah, you can take the ruler or you can take a pencil. You take a ruler and a pencil, and then you're gonna mark the points of interest. Here's are the points of interest. It's going to be number 1, your x-intercept. Number 2, it's going to be your asymptotes. After asymptotes, what are we gonna have? X-intercept, asymptotes. Okay, also the points of intersection. Points of intersection. And then, yeah, that should be about it. Yeah, points of intersection, asymptotes, and x-intercept. Yeah, so the graph is gonna be a bit messy, guys, so please bear with me. I don't know if you even gonna see this, but I'm hoping that you do. Let's see. Okay, so this is what you're gonna do for me. You are going to go to the x-intercept. Remember, this is an x-intercept. So what you would want to do there is to have a line coming straight up. Take your ruler and just divide this, have a line that is straight downwards there. Also here you see it's a point of intersection. It's also part of the points of interest. So you want to take your ruler again and then run it through those at that point. Oh, a bit difficult for me without a ruler because I'm trying to use a highlighter. You're very bad, sorry guys. And then you're gonna have this. Okay, let's go. Yeah, then you're gonna have this. Okay, then you're gonna have this. You also run it through the asymptote. Remember, it's a point of interest. Then you're gonna have this. This is 4 there. Oh, yeah, no, doesn't look too nice, but let's see if we can get something from it. Right. Okay. But when you do yours there, guys, I hope it's visible nyana, because mine not that visible, but I hope you can see the different sections of your graph. Are they visible? Okay. So let's start with an easy question. The question will say, determine for which values of x, for which values of x is, let's just say, remember this is g. So let's say is g of x greater than 0. Now, in these questions, I need you to know that this means above, and then this means below. So when it says that for which values of x is g are greater than 0, what it means is that where is the graph of g above 0? When we say above 0, we mean above the x-axis. So if you can check, this is the part whereby f is above 0. G is above 0 here. You see, it's above 0. And then when we check at the bottom here, it's it's not above 0, right? It's not above 0. So what we can then say, to answer the question, we can then say g is above 0 for values of x. Remember now, we are starting from this green line. That green line, the x value is -2. So you say for values of x that are greater than -2. Then you are done with the answer. That's the answer. Because we are saying from this section, the green line, to the end, g will be above 0. That's what it means there. Did we get it? Are we together, Miss Katleho? Okay, so what about where f of x is greater than g of x? Right. where is f greater than g? So for this, right, what you want to do there, you're gonna zoom in a bit. For me, I have to zoom in here. We need where f is above g. Remember that is what that symbol means there, above g. So here is f, the red line. Where is the red line above the blue line? So I will show you here. That's why you must have highlighters. If you have highlighters, this becomes quite easy. So you see here it's above, and then also, oh, okay, and then it's not codable, guys, but I want you to section. Actually, the red one is still above here. You understand? So this smaller section between these two x values that are drawn by the, where these two green lines touch the x, those are your x values. So we can say those are the only two regions, guys. I don't know if you see another whereby f is above g, but those are the only two regions. Remember, we move from left to right. So whenever you're looking at this, move from left and then move on to right. Okay, you're always moving from left to right. So how do I say that? How do I answer the question? It's simple. You tell them that from this green line all the way to negative infinity, the red graph is above g. So you tell them that x there is less than -1. But it's not only this region, there are two regions. So you're gonna say or, you say or, then you go here and then you say the region is between these two green lines. The two green lines, the x is 3, the other one is 4. So therefore you say or x is between 4 and 3. This is how you write between 4 and 3. You write x in the middle, then you write these two symbols. They must face this direction. Same direction. They must all face to the left like that. So please, when we do it, let's do it proper. So this is a way to say x is between 3 and 4. Those are the two regions. And then where is f of x less than g? Right? Where is f of x less than g? Well, this means where is g above f or f below g? So let's look at it. G. Look at g is above here. It's above here. And then also g is above here. So it's also two regions, right? So those two regions, how we classify them? So we are gonna say those blue regions, just focus on the long low lines. The blue region, the first blue region starts at -1 on the green line. I mean, it starts on -1 and then it ends at what? It ends at 3. So you're simply gonna say x is between 3 and -1. Then you say or. Then you go to the second region. The second region starts from 4 until infinity. So you're gonna say the x is greater than 4. Then you are done. When they ask you where is f of x, where is f of x greater or equal to g, this still means that f must be above g, but just that this you include, this means include the intersection points. Remember those points of intersection, it means include them. Okay, include the intersection points. Are we still together? Great. So now let's go back to when it was like this. Remember we had said x is less than -1 because that is where f is above g. So therefore the answer now is going to be x is less than -1 again, but you also include -1 as part of the intersection point. Then you say or, remember we had said or x must be between 4 and 3, right? So therefore um is it 4 and 3? Yeah, 4 and 3, which was this small section, eh? So on that small section you're gonna include 4 because 4 is part of the intersection points. But then when you look at 3, 3 is an asymptote. So unfortunately we don't include the asymptote. So don't put or equal to on the asymptote. Wherever you see the asymptote, you never put or equal to. Okay? Are we together, guys? X cannot equal 3. Yes, yes. No, if you say, like, are you saying you're gonna write this and then write x cannot equal 3? No, it doesn't work like that. It doesn't work like that. But yeah, but that's how you do this, guys. I hope this is clear, guys. As long as you have your lines, I think your life is gonna be easy. You just have to look at where this is below, where this is above. That is it. Is there any question? Oh, is there any question? Yo, kajua kinako. 5.6, ne? Okay. So 5.6 is x is less than 3 and determine the values. Oh, okay. We already did it, sir, but then it's fine. So look at this. Whenever they ask you questions like this, you ask yourself, which graph is this? Which graph is that one? That's the hyperbola. So we are talking about f of x. Where it is less than, which graph is this? That's g, right? So we already answered that one, whereby we said f is less than g here. Ne? Yeah, so they just that there they gave a restriction. They said if x is less than 3. So which tells you that you don't have to include this part, this one. You just have to talk about this one. Okay? Yeah. But do you get how to work around it? Okay, perfect. Any questions, Ms. Katleho? Do we understand all? Okay. All right. I so wish maybe we had time to talk about parabola and stuff, but even there it works the same way. For parabola, there, just do the same way. Draw those lines, but for parabola, also have a line that is cutting it in half. We call it your axis of symmetry, which is on the turning point. Draw a line straight that is cutting it in half. Draw lines on its asymptotes. No, not asymptotes, on the x-axis. Yeah, x-intercepts. Draw lines there. Then you'll be able to compare them as you go. Otherwise, everything else is standard. Calculating x-intercept, calculating y-intercept, points of intersection, and then looking at where the graph is above, below, and stuff. So everything else is standard. Just also revisit finding the equation of the graph, right? Especially for a parabola. In terms of exponential, is a similar way. You're gonna have just a horizontal asymptote for exponential, but know how to sketch your exponential. Okay. Otherwise, guys, all the best. Tell me how it goes tomorrow, and then if there were any challenges, you just tell me so that perhaps as we move, we can be looking at them. Is that okay? Man, if well, I trust in you, man. So anything is possible. Yeah, yeah, yeah.